So in the yesterday class, I have explained the moment of couple. That means the force that are parallel, opposite in direction and the equal in magnitude. Suppose you just visualize one example. You want to open the cap of a jam. Like you want to open the cap. Obviously, you will open like this. You will open like this. So in this way, this is the ideal example for the moment of couple, where the two forces, like one force, you will hold the cap in like this. So one force is, it will act over here. The other force, that is here. These two forces are equal in magnitude. You can say opposite in direction. This is direction, one force, and this is the direction of other force. And they are parallel, equal in magnitude. So now I am going to explain the mathematical expression. Same thing, the mathematical expression for the moment of couple. These derivation is very important for the numericals. First of all, I have taken one rod. Look at this. I have taken one rod A and B. And this O, this is a simple rod, and this O is known as the turning point, or in other words you can say the pivoted point. When the pivoted point is not given in the numerical and simply they have provided you one simple rod, that means it is the obvious. That means this rod will circulate about its center point. So in this way, it is obvious, or you can say it's a universal truth. For a simple rod or for any straight thing, you will always assume the pivoted point or the turning point in the center of that rod. As I have given the example, this rod AB and this point O. This is the O point, that is the turning point or the pivoted point. And at the point A, force is applied like this. This is the direction of force. This is the direction of force. Force are applying over here. And the other force at the B. This is the direction of force. So when you are applying the force, that means couple of forces, it's going to be turned down, and it is going to be turned down about the point O. So there are this O point is known as the pivoted point or the turning point. At the A, one force is applied. At the point B, one force is applied. And this is the line of action, imaginary line drawn from the point of application. So this I have drawn the imaginary line from here to here. This is the point at the point A, and here to here for the point B. At the A and B you have applied the forces, and by which it is going to turn in the clockwise direction. Some more technical term, A and B. This AB, at which you are going to apply the force. This AB is known as the arm of couple. Why these are known as the arm of couple? Because at A one force is applied, and at the B the other force is going to be applied. So the distance between and what is the perpendicular distance? Always try to understand, then only you will be able to solve the numericals. So at the A and B, two forces are applied, and this AB is known as the arm of couple, because by these two forces there is going to be couple is formed. So in this way, this AB is, what is the AB? Perpendicular distance between the two forces. So AB is the perpendicular distance. This AB, this is the point O, it is the perpendicular distance between these two forces. These forces rotate the body about the point O, and these two forces at A and B, these two forces rotate the body about the point O. This about word is very important, and about the point O, that's why this O is the turning point or the pivoted point. So come to the rule. If you find out the moment of force at the point A, moment of force F acting at the point A, and in that case, this is at the point A, that means the perpendicular distance you will have to take, that is OA. This is very important because this is the pivoted point, and what is the moment of force? The moment of force at a point is, that means the perpendicular distance from at the point of application of force to the pivoted point, that I have already explained. So here is the difference for the force F. The difference is OA. That means the moment of force at the point perpendicular distance from the pivoted point. So if you throw the perpendicular distance, this is the point of application of force, and the perpendicular distance from the point of application of the force is OA, and direction is clockwise. So you can write moment of force F acting at the point A, that is F into OA, because this is the turning point or the pivoted point or the axis of rotation. It will remain, it is a universal truth, it will lie in the middle of the rod. So you have taken F into OA and direction is clockwise. Again, moment of force F acting at the point B. What will the moment of force acting at the point B? Because this is the point of application of force, perpendicular distance from the pivoted point or the turning point. The perpendicular distance from the pivoted point, it is OB. So at the B, the moment of force, again the direction is clockwise, that is F into OA and the F into OB. Now, moment of the force of couple. When both are in the same direction, both are in the clockwise direction, then it means you can add it. So, moment of force of couple. What is the moment of force of couple? When both are in the same direction, that means they are not going to cancel each other. So, what is the logic? You will add this. And moment, and the term will use moment of force of couple. Couple because the two forces are involved and the direction is same. When the direction is same, the first it is F into OA plus F into OB, because they are not going to cancel each other. Both are in the same direction. Simply you will add it F into OA plus F into OB. That means when both the forces are in the same direction, you will add it. So F into OA plus F into OB, you will take common F and it will come OA plus OB. OA plus OB. And OA plus OB, in other words, it is the distance AB. So you can write down F into AB. And what is the AB? AB is known as the arm of couple. Arm of couple means the perpendicular distance. This is the perpendicular distance between the two forces. So you will get the formula, moment of force of couple on any single rod will remain F into AB, and this AB is the arm of couple. And one more formula is, that means moment of couple. So you can take any force F and F, because I have already told you that both are equal in magnitude. So either force, you can take any force into perpendicular distance, into the perpendicular distance between the two forces, or you can say the couple arm. So you will get the formula, moment of couple is equal to, for the simple rod, it is F into couple arm. Couple arm is the perpendicular distance between the two forces. Now, you can, how will you write in the definition form the moment of couple? What is the definition of moment of couple? It is equal to the product of either force. You can take, it is the product of either force, you can take any force, and perpendicular distance between the line of action of both the forces. That means the perpendicular distance, this is the line of action of one force and this is the line of action of one force. So there are the several words for this AB. This AB is known as the couple arm. This AB is known as the perpendicular distance between the two forces, or in other words, this AB is the perpendicular distance between the line of action of both the forces. So don't get confused. All things are the same. Whether you can say it's the couple arm, or you can say the perpendicular distance between the two forces, or you can say that it is the perpendicular distance between the line of action of both the forces. Now I am coming to the numericals. How will you solve these numericals that are based on this concept?